good that you mentioned this actuation technology, because I was about to somehow move us from this very exciting topic of social touch, and because there's so much to talk about, but we have a time limit, so I wanted to move into this direction of design space actually, and design process for sense of touch, right, or mediated touch. So if you could talk about your design process in general for when you design for social touch, and what aspects of design space do you consider and how, because in haptics it's not a very stable field yet. We don't have like standards, golden standards like in visual modalities or visual interfaces, but there are still certain pillars, right, that we can like base our design process on. And maybe you can take like an example. Let's say if you're designing a special wearable for social food interaction using haptics, and you design it for a specific body part, then maybe how, like, you have a goal, right, for, let's say, enhanced food experience. You have some sort of research questions. So now what will you consider as your, let's say, golden blocks for designing that particular piece of wearable? I mean, hypothetically, but just like, how do you think as a designer, as a haptician?
Yeah, so I think your remark that, and that's something that I think we say a lot in this field, there's not so much ready-made hardware available. So if I have colleagues that work on sound, they can buy all kinds of speakers and microphones, etc., to run studies. And I think that's much less the case in haptics, where we do have a increasing number of hardware actuators that are quite readily available. But that definitely hasn't always been the case, and it still requires a lot of tinkering. So I think that's definitely one of the starting points in my process always is start from, let's make something small that works. Doesn't have to do anything very special, but use that as a stepping stone for creating more sophisticated experiences. And I always also do that in collaboration with other people. So I'm not an engineer by training, so I can embody ideas in a simple prototype, but I always collaborate with others to bring them to a next level where more interesting interactions are possible through these technologies. So in my past work, I've used a lot of vibration type of actuators, so ERMs, but also voice coils, simply because they're cheap, they're quite easy to drive, and they can create a touch experience on different parts of the body in a small form factor. So they're just an easy type of technology to work with. More recently, I've also started collaborating with material scientists in our faculty, so that work on shape memory alloys and magnetic materials. And there we really take a material-driven design approach, that we start from the material and trying to figure out different configurations of the material, and from there think about what could be the applications of this for haptics in this case.
But very good point. But this is already like a side of the technology, right? This is like already a point where you're ready to select your actuation technology and embed it. But before this even happens, how do you start a design process, in a sense, right? What do you consider? Body location, the actual interaction, or the type of gesture or touch, because then that would probably lead you to the decision on the actuation technology, right? And where and how many actuators you want to use, right? And how. So would you be able to talk a bit more about the beginning process of the design?
I think there's two aspects to this. So the material-driven design process that I mentioned is actually sort of flipping that model around, because normally you would say, okay, we have a certain research question, we want to enable, let's say, a CT afferent-like touch. How can we do that in a setup that allows us to experiment with that? And that might then result in this, a vibrotactile array that can generate these kind of motions over the skin. So that, I think, is really starting from the question that you have and thinking about the available technology that's there. At least that's in my case, the process, and trying to see how we can answer that specific question through a process of prototyping. The material-driven design process that we've used for these smart material haptics is sort of flipping that model around, where we start from the material and then come up with questions to ask, where could this be applied? How could this be applied? What form factor should it be integrated in? So it really starts from the material itself.
Okay,
so these are two different processes. Yeah.
Right. Okay, great.